So hey guys, so today we are going to talk about the latest Snowflake Arctic model that has been released 2 days back by the Snowflake AI research team. So actually I also want to talk about the concept that LLM stagnation has actually come to become a reality, right? Because no new innovation has happened in the past 3-4 months if you say, and a lot of new models have been released constantly. So yeah, let's start with exactly what is this Snowflake Arctic model, and then we are going to talk, is this model really helping solve any problem or setting any new benchmark. Let's see. So uh, if you look at the size of the model, they have also open source the model, so that's a very good thing. So it's a 482 billion parameters model, right? So now if you look at the training and everything, so the compute that they have used, they have mentioned the two models that they have open source, the base model and the instruct model, I guess. And if you look at the results, right, model architecture and training compute for Arctic, so they have even benchmarked the Llama 3 model, so that's a very good thing. They are up to date. So it's also a MoE hybrid model, so this is also a mixture of experts, hybrid transformer architecture, they have used that only. So uh, I think 480 billion parameters are there, they doing the top KS2. The experts are 128, so that's a very big number, 128 experts, because the Mixtel models also have 8 experts. And at a time, right, active billion parameters are 17 billion. So that's a bit different because the number of experts is a lot. So they have used 3.5 trillion tokens for training, and the point is 15 trillion was used by Llama 38 billion. So so yeah, that is something, because they Llama 3 proved that the scaling laws are not always applicable. They went a step ahead and proved that you don't need to always follow them, right? So now if you look at the architecture, right, this is the Llama 2 Llama 3 architecture, the same. And then you have the MoE transformer, so the mixture of expert. So this is the Mixtral model by Mistral is actually following this only. Then you have the Dense-MoE Hybrid transformer. If you guys want to talk in detail about this, I'll make a separate video talking about this architecture. But before that, you obviously need to know about the mixture of experts, so maybe we can start with this, then I'll show you this. Cool. So if you look at the result, the data category before the results, so they have the web data, the code and SQL, the STEM data. So the phase one, they have used 75 this, 62, and so yeah. So they, during the whole training, I think they made sure that they are focusing mainly on the enterprise version, right? Because that is what they are actually expecting this model to be good at. So if you look at the active parameters, they were, as they mentioned, uh, it has a lot of parameters active at the same time. So I think 17 billion parameters, right? So uh, now if you look here, so 65% is the enterprise intelligence, they what they say the active billion parameters is this. So the best performance slash cost ratio, they say that Llama 3 billion is almost put in the same mark, and Mixtel is obviously far better. So I exactly don't understand that if this model is not defeating any other model, how is this solving any purpose? But yeah, so if you look at the SQL generation, so it is not outperforming any other model. I think the Mixtel is still the best model in this case. And same in coding, same in the instruction following, same in the math. If you see, even in some cases, the Llama 370 billion is even close to it, right? So for I don't know, 482 billion parameters versus a 70 billion parameters model, is it even a fair comparison? And in some cases, it's even outperforming. So was this model actually necessary? I don't know. Maybe they have some special purpose for this model. So now if you look at the full metrics table, comparing the Snowflake with the latest Databricks model and the Llama 38 billion and Mixtel model, so you'll see the results that we were talking about. So in SQL generation, right, it's getting 79 and Llama 3 is 82 and Mixtel is 79.2. So it's the third in this whole thing. And if you see the active parameters, right, 17 billion only. But obviously you will need to load the whole model, right? So that's the point. So if you look at the human evaluation, uh, it's 71.9. So Llama 3 is actually very good model right now. Similarly in instruction following, I think Mixtral is outperforming. But yeah, if you look at the total number of active parameters, it's far less, 17 billion, and it has 44 billion. The reason is it has 3 billion models, and I think total 128 models are there, right? It's a 3 into 128 times model. So they have actually enable even it on their server, so if someone wants to test, they can go. And Microsoft Azure is everywhere. A model gets released and it's there. So yeah, it's they are actually pretty good in this field. They are acknowledging all the models that are there, even if they are not even giving state of the art performance. So even though, so they are giving. So this is the model, this is the base model. So you see here, right? So 0 downloads are there. I think maybe just because it got released one day back, the things are not updated here, but from what I know, in every 12 to 16 hours it gets updated. So but the whole point is, who is able to download even this model for testing? It's a 482 billion parameters model at last. So just like Grok, I think maybe this model looks good on paper, but even if a developer wants to try this, it's impossible, right? Because you'll require 800 GPUs. That too, I think, at least you need multiple GPUs, 800 GPUs, right? Then only you will be able to do that, and I don't think everyone owns that. Personally, not compared to the organization level, right? So they even say that while training, they leverage the deep speed and VLLM, so that helped them a lot in scaling the training part. So yeah, they use the paged attention also for this, so it's good. Paged actually VLLM paged attention are really good. Even during working with Komodo and Billion, I use them, so it helped a lot even during inference. So the architecture is somehow a bit different. They are using the Dense-MoE. So you see this, the max memory is 150 GB, so looks awesome. Now similarly, the instruct version is the same. I think these models serve a particular purpose in their enterprise, but not for the general audience. So I don't know if this model was actually required, because Snowflake a few days back released the world's best practical text embedding, and it actually looks good. They are solving some problem, right? So what they say, at least in their benchmarking, in the retrieval score of the MTEB, that they are outperforming all the model, the Google Gecko, the OpenAI embeddings, the Cohere embeddings, and the BAIBG large. So I have used it a lot. So what they are showing, that they are outperforming it by at least 1.5%. So it looks good. And similarly, if you look at the size of the model, so it's 23 million parameters, I think, and the biggest is 334 million. So they are achieving plus 503. So that's a very good number. So the MTEB score of the retrieval is actually a very important score when it comes to people who are working on RAG architecture, right? So if you are able to improve on this, it proves that definitely your embedding services will be used by people who are working on the RAG architecture pipeline. So I personally think this was a very good thing. They have even open sources, so anyone can go and use it. But the whole point is, for the Snowflake Arctic, actually it doesn't make sense to me, right? Because this is what is happening. People are actually just making the models big. No innovation is happening, but the training data is increasing. Most of that data is synthetic only, and we are actually reaching a stage of LLM stagnation. So the innovation is almost coming down to zero, and the data is increasing, the training is increasing, the SFT part is only being applied to the trained models. No pre-training, no tokenization, fertilization, analysis, nothing is being happening, right? And even the Llama 3 model, to be honest, they haven't, as they mentioned, made any changes in the architecture. It's same as before. They have just the scaling laws that were applicable last time, they have not mentioned them this time. They have exceeded the part that was mentioned in the one. They have used 15 trillion tokens. That's it. Everything is almost same. They have used the same embedding structure and everything. So maybe after a few months we will be seeing some changes, but I don't see in the coming months any good changes in the architecture level, or any major changes in the LLM community, which can actually help us scale our models to a next different level. Even if you look at 5.3, right? 5.3 doesn't introduce anything new. It's just new data has been added, the parameters have been increased, and maybe they have made it eligible for iPhone. That's it, nothing new. So yeah, let's see, let's wait. I'll link down all the resources to this video in the description as usual. You guys can go and have a look and suggest me what we can talk about in the next video. So thank you and have a nice day.